Tell me what happens. Sends out an electromagnetic wave that we can't see with our eye, right? And where does it send it? In every freaking direction, right? It's going up. Right now, all of our phones are sending out signals we can't see, right? Just everywhere, going through the walls, going through our bodies, everywhere, right? These waves go out, and then what's sitting somewhere around here? A cell phone tower, right? Cell phone tower, and on these towers, they have these little boxes on the top, and if you could get into those boxes, you would see a parabolic receiver. It's a parabola, it's a shape of a parabola, and what it does, it's like a big ear, and it listens, and it takes this signal, and it's like the flashlight, but reversed. Think about that flashlight. You had this light here shining out. Imagine the beams are coming in instead, and they all get reflected down to that point. And that point is called the receiver, and it's listening, and it basically gets that signal from the phone and says, oh, hey, this phone is trying to contact another phone. That other phone, where is it? Somewhere else, where someone else is, right? Their phone is sitting here talking silently to a tower over here. And so this tower knows right now, this tower knows that this person's phone is right here. And so when this tower says, hey, that phone's trying to contact that phone, it knows exactly how to send it to the next tower, and it sends it all through these towers. They know where you are, right? Right now, your AT&T, Sprint, they know exactly where you are, or else you couldn't get your call, right? They know, well, within a certain radius, they know where you are, right? So they send that signal, gets sent, boom, 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 down to there. And that all happens almost at the speed of light, right? You make a call, boom, you're talking. There's no like lag. Without parabolic receivers, you can't do this. You have to have parabolic receivers. What about this scenario? Other side of the world. We have towers, right? We have these towers here that are listening to our cell phones. Do we have towers all the way around the world? We have oceans between continents, right? So you can't have towers across, so what do we do instead? We send it up to the satellite in the sky. What does satellite look like? It looks like a freaking parabola, because it is. It's a parabolic receiver. So the signal goes to the tower says, oh shit, this person's on the other side of the world. So I'm gonna go over to the next satellite, and then back down to a tower, and then back down, and that all happens again like that, right? So every day, we're sitting here, when you're streaming a video, right? When you're sitting there watching a video on your phone, there are millions of little signals, little zeros and ones floating into your phone from some other place. It's almost over, like, isn't that crazy to think of that? How much data is just floating around in the sky right now? If you could see it, imagine you could see it, right? Imagine you could see all the waves. What would it look like? Chaos. You'd be blind, right? It'd be blind. You couldn't see in front. You would just literally be like almost in a completely blacked out room. That's what it would be, because you would be completely blind by the amount of shit that's floating around everywhere. Look, that's a wireless projector. I can connect to that projector wirelessly. So it's sitting there right now, sending out, saying, I'm here, I'm here, I'm here. And this one, my computer, I can send a signal, and it's all, right? It's crazy how much stuff. But anyway, parabolic receivers, right, are important. So that's why we study them. We study parabolas because we needed to in order to understand the world and get our technology better. How are we doing? All right. So we are going to get into the nitty-gritty now, to the details of how we will go about sketching parabolas. So we already talked about the vertex, right? Right. Okay. Now, some other things that we want to talk about when it comes to parabolas and quadratic functions. So, other properties. So I'm going to go off topic here a little bit, just for a minute. So when I was your age, like most of your ages, I grew up like high school and college times were in the 90s for me, okay? And this is like before cell phones. So like on the weekends when you go out with your friends, you'd have to make a plan, right? You'd have a plan. We're going to meet up at this time, right? Nobody had phones, so it was like, at least where I grew up, you would have these huge parties with like hundreds of people in a field somewhere having a party, and it would never get busted by cops because like no one knew about it, right? Only the people that knew about it, right? And so the point I'm making is that the technology is great, but actually it kind of sucks too, because nowadays like kids can't do things like, you don't just like leave on a Friday night and disappear. You're always like, you know, you're always connected. And even more sad is that like kids growing up now are at school and they're sitting there with their phones all day long with their phones all day long. They go home on their phones all day long. They never actually have a chance to like disconnect from the social crap that happens at school, right? Like when I used to go to school, if something shitty happened, at least I got to go home and you know what? Next day is the next day. You know, it's a new day, whatever happens, happens, right? But now it's like something shitty happens, you go home and it continues to be shitty. And you wake up in the morning, it continues to be shitty, right? Because everyone's so connected to each other. I mean, seriously, I mean, there's pros and cons to the technology we have. I feel bad for, you know, the generation who's grown up with that just thing that just is attached, right? It's not anyone's fault, that's just the way it is. So anyway, I'm off topic. All right, other properties. So if we have a parabola, again, those are the two scenarios. We already talked about the vertex. If you draw an imaginary line through the parabola like this, we can see that for all parabolas, there is symmetry along this dotted line. In other words, it should be a mirror image of itself on that line. And because of that, we call this the axis of symmetry. Oops, symmetry. The axis of symmetry. That's another property of lines. We need to know that. What's the axis of symmetry of a parabola? Oh, it's that imaginary line that kind of creates a reflection over that line. The other important characteristics or properties are if the graph ever hits the x-axis, right? Those, of course, are called x-intercepts, right? X-intercept, x-intercept. And we may also have a y-intercept, or well, we will always have a y-intercept, right? This right here would be a y-intercept. So when we look at quadratic functions, we're going to be interested in knowing, does it open up or down, right? Does it open up or down? Where's the vertex? Where's the axis of symmetry? Does it have any x-intercepts? Where are they? Does it have any y-intercepts? Yes.
I was going to ask a really good question.
Okay.
Vertex always be along. If you find the vertex, haven't you already found the axis?
Exactly. If you find the vertex, right? If you find this vertex, then you know the axis of symmetry, don't you? Okay. All right. So those are the properties. Those are the things we're going to be looking for. And I'm about to give you the set of steps, and we're going to try and do an example. But I need to ask you about x-intercepts. When it comes to x-intercepts, how many will we have?
We'll only have 2. 0 or 2.
Well, in the pictures I drew, right? In the pictures I drew, we have 2, don't we? So does everyone agree that 2 is possible? Yes? If you draw me a parabola like that, it's possible to have 2 x-intercepts. All right, can you have 3? No? 4? Is that obvious to everyone that there's no way, if you draw U like this, or you draw it like this, there's no way you could ever hit the x-axis more than twice. Is it possible to have 1?
Yes.
Yes. How? What would it look like? Let me draw an example over here. If the vertex happened to be on the x-axis, like that, or, I'm going to draw another one here. In those two different scenarios, these are two different parabolas, all right? But in this scenario here, we would only have one x-intercept, right? And here as well. So it is possible to have one, yes?
Is it also possible to have 0?
Can you have none?
Yeah, can you have none?
How would you have none?
I would suppose if you shifted the function up at least 1.
Like that?
Or yeah, like that.
Or if it opened down like this, right? So it is possible to have none. But that's it. For all quadratic functions, we can only have 0, 1, or 2 x-intercepts. That's it. All right, so what we're going to do now is this. We're going to put a list of steps on how we're going to sketch a quadratic function, all right? And our goal is going to be to figure out if it opens up or down, to figure out what the vertex is, to figure out what the x-intercepts are, right? How about y-intercept? I didn't mention y-intercept, sorry. Y-intercept. How many will we have?
1.
1? There's 1.
There will always be 1.
It's always 1. No matter how you draw it, this one would eventually hit. This one would eventually hit. This one would eventually hit. But you will only have 1. Okay, so y-intercept, 1 only. All right, let's write the steps down. I'm going to put the steps, they may not make sense right away, but then when we do an example, hopefully they will. Okay, how to sketch a quadratic function. Actually, don't need this. How to sketch a quadratic function. All right, the first thing we're going to do is figure out, does it open up or down? Right? Does it open up or down? And that should be easy because all we have to look at is what? A. A will tell us that. The second thing we're going to do is we're going to find the vertex. Okay, have I discussed with you how to find a vertex yet? No, I have not, right? I have not. But what I'm going to do right now is I'm going to give you a formula that allows you to find it, all right? So to find the vertex, here's what we do. Remember, the vertex is a point, hk, right? The h will always be negative b divided by 2a. So remember, a quadratic function looks like ax squared plus bx plus c. The h for the vertex is always the negative of the b divided by twice the a. Always and forever, that's what it is. And then the k is what we get when we take that answer we just got and plug it into the function. Whatever comes out is the k value. Now is the k. The k is what you get when you plug h into the function. H, you just do a little computation. So you might ask yourself, where does this formula come from, right? It actually comes from calculus. In calculus, we can prove this formula. So for now, just accept it, and then when you get to Cal 1, hopefully they'll show you where it comes from, all right? All right, so that's how we find the vertex. The next step, okay, this step right here, I'm going to actually circle this in blue because this step, I don't know anyone else that does this step. I do it, but I don't know anyone else who does. So if you go get help tutoring, they might not know why you're doing this, but I'll explain why I do it in a second. We're going to do a quick sketch here. We're going to do a quick sketch. And the reason we're going to do the quick sketch is that this will help us determine, this determines the number of x-intercepts we have. And you'll see when we do it how we're going to be able to easily tell how many x-intercepts we have by doing a quick sketch. So we figure out, does it open up or down? We find the vertex, then we do a quick sketch. After we do a quick sketch, we're going to find the x-intercepts. Right? If we have any, right? If we have any. If step 3 tells us we don't have any x-intercepts, we won't do step 4. But we'll find the x-intercepts. How do you find the x-intercepts for any function? If you give me any function, how do you find the x-intercepts? Solve it, what do you mean? Solve it, set the function equal to 0. Okay? So to find the x-intercepts, we will set the function equal to 0 and solve, right? And solve. Which means we're going to have to solve what type of equation? A quadratic equation, right? Which means we either need to know how to factor or we need to know how to use the quadratic formula, okay? Those two things. Step 5, find the y-intercept. We are guaranteed to have a y-intercept. And to find it, all we do is kind of the opposite of this. Instead of setting the function equal to 0, we plug 0 into the function. And whatever we get out is our y-intercept. And then the 6th and final step is to sketch it. All right, I have 15 minutes. Let's do an example. And I'm going to start with a very simple example. Something that's easy to work with. All right, sketch this. F of x equals x squared minus 6x minus 7. All right, is that a quadratic function? Yes? I want a detailed picture of this quadratic function. Detailed. This is not like the previous section where we were just trying to like move things around up and down. In fact, we couldn't do that here because, look, if that minus 6x wasn't there, then you could do just a shift, couldn't you? X squared, move it down 7. But this minus 6x in the middle throws everything off. You cannot use what we learned in the previous section. All right, step 1. Does it open up or down? You know what maybe we should do? Maybe we should write down what A, B, and C are, because we're going to need it, aren't we? What is A for us here? 1, B, -6, and C, -7. Okay, that's just for reference. Okay, so A, part 1. Does it open up or down? It opens up, right? How do I know it opens up? A is what? 1, which is positive, right? This is positive, opens up. Step 2, vertex. Okay, to find the vertex, I need to find h and k, right? I need to find h and k. Thank you, calculus. Actually, thank you, Isaac Newton. Isaac Newton was the father of calculus. Did you all know that? Also what?
Gravity?
Yeah, well, laws of motion. Newton's laws of motion. Newton was a shit. Like, really, he was. But he's got math stuff, he's got physics stuff. But Newton has a famous quote. Have you ever heard this quote by Newton? It goes, and I may be off a little bit here. He said, "If I have seen farther than others, it is only because I have stood on the shoulders of giants." I don't know if it's farther or further. Farther? I think farther, right? If I've seen farther than... It's a pretty good quote, huh? Okay, vertex H. I need H. So Isaac Newton went to school, right? Went to college and basically absorbed all the math and all the physics that was known at that point in time. And then went home and basically working like a shed in his backyard came up with calculus. Like developed it on his own.
So he's the guy in a punch.
He's what?
He's the guy in a punch.
You know, I was talking to my daughter about this the other day because one of the challenges as humans, right, existing in this world is where are the frontiers, right? Like in Newton's day, the frontier was right there. He went to college and, oh wait, we don't know anything else after this? Well, shit, I can go, you know, there was a frontier. No one had been past that threshold yet, right? There's all these frontiers. Where are the frontiers now? The frontiers require tremendous amount of money or a tremendous amount of time, right? You think you're in college to learn things that we already know. Like this has all been learned, right? But you can't get to the frontier of your field, your STEM field. You can't get to the frontier of that until you go and learn all the stuff that's been learned up to this point in time. It's like you have to catch up with where we are right now. You can't just jump to the front and be like, okay, where are we? You know, what do we not know? No, you got to figure out how we all got to that point. Does that make sense? So it's really challenging to find the frontiers. Okay, man, I'm off topic today. Okay, negative b over 2a. I'm doing this. What's negative b for us?
6.
Positive 6, right? Because we already have negative 6 up there. So the opposite of b, that's the way you look at negative b. It's the opposite of b. So the opposite of this, 6 over 2 times 1, right? 2a. And that's just 3, isn't it? Ooh, nice number. I told you this first example, so I kept your numbers nice here. All right, now we need k. How do we get k? We take that answer, 3, and plug it into that function. So what happens if you get h wrong? K's wrong then, right? You're going to mess up k. So h is real important because if you don't get h, k is not going to happen. Okay, now plugging in. 3 squared minus 6 times 3 minus 7. 9 minus 18 minus 7. Negative 16. Is that all right? Okay, so my vertex is a point. It's the point 3, negative 16. That's the point, 3, negative 16. Step 2. Step 3. Quick sketch. This is that step that not a lot of people do, but watch. Here's what I know so far. The vertex lives where? To the right, 3, and down 16. So somewhere down here, right? I don't even care where it is. Somewhere down here, right? And it opens up. So that means this must be the lowest point, and that means it must look like this, right? I mean, just real quick, this is what it should look like, yes? Generally? So how many x-intercepts should I have? 2. Do you see how this just automatically tells me I have two x-intercepts? I have 2 x-intercepts there and there. I don't know what they are, but I know I have 2. What if this thing this was the vertex, but it opened down? I would have no x-intercepts, and I would skip step 4. Okay, I would skip it because I'd have none. Why go look for something you don't have, right? And step 4 turns out to really kind of be the hardest part of most of these problems, step 4. So if we can avoid it, let's avoid it. All right, here we go. Step 4. Find the x-intercepts. I have 2 of them, right? So I take the function, I set it equal to 0. It's a quadratic equation. You have different methods to solve this, right? I made this one so it factors, so we can go quickly through it. Right? This does factor. Minus 7 plus 1. Do we agree? And that gives me, set those 2 equal to 0. And we get our 2 solutions. X is positive 7 and x is negative 1. There they are. What is your other option if you can't factor? What's your other option to get to these answers? Quadratic formula. It takes more time though, right? And then there's places where you can make mistakes, and we should get the 2 answers. Questions there? Step 5. Step 5 is the y-intercept. How do we find the y-intercept? Just plug in 0 for x into the function. And what do you get? Negative 7. Negative 7. That's what happens when you plug 0 into that function. In fact, won't it always be c?
Yeah.
It'll always be c, because that'll be dead and that'll be dead from zeros in there, and then you just have the c at the end. All right, I'm ready for a picture. So I'm going to start with the vertex. My vertex was, what, 3, negative 16? I'm going to go to the right 3. 1, 2, 3. Now look, as I'm drawing this, here's my 3. I'm going to go down 16. I'm also going to kind of, while I draw this, take a look at where my x-intercepts were. Right, negative 1 and 7. Negative 1 and 7. I'm just trying to make sure I have enough room for everything here, okay? And then I need to go down negative 16. So here's how I'm going to do it. That's negative 5. That's negative 10. It's negative 15. Do you all see that my scale this way is not the same as the scale this way? Like 1 tick mark here is not the same as 1 tick mark here. Do you all see that? That's okay. That's okay to do. Go 3 units here, and then down I need to go, what was it, negative 16? Yeah. I'm going to put a dot here, and I'm going to label my point. 3, negative 16. The next thing I'm going to do is label or plot the x-intercepts. The x-intercepts are negative 1 and 7. So here's negative 1. And 7 is, let's see, if that's 3, that's 4, 5, 6, there's 7. Okay, those are my x-intercepts. I'll go ahead and label those. 7, 0 is that point. This point is negative 1, 0. What else do I have? A y-intercept. My y-intercept, I'm doing it in a different color, but I have no idea why. I'm just going to do it anyway. There's negative 7 as a point. Let's write it this way. 0, negative 7. And that's it. That's all the information. So now what I'm going to do is I'm going to draw a parabola. And it is not a v, okay? It's not the absolute value function. It's a curve. And it needs to be symmetric, which means that if we imagine an imaginary line through here, if you imagine a line that goes straight through the center of this, it should be a mirror image of itself over that line. So, you know, do your best. I'm going to start on this side because I've got 2 points over here. So it's going to go like this, and it's going to curve down. Curved, right? Not a V, and then back up like that. There we go. Good enough. Yeah? Okay. So I'm almost out of time. What I want you to do for homework is the homework for 3.5, and I want you to sketch the following 2 quadratic functions. All right? I'm going to put them on the board. The 3.5 homework, just, the 3.5 homework, do that for your own benefit. These 2 problems I put up here, I want you to turn in next class. I want these 6 steps. These six steps for these 2 problems, all right? The first, yeah, I want you to go through the 6 steps. And then I want a picture at the end. Yeah, don't just turn in a picture. I want all the work. Okay, so this is, and let's make this a quiz, all right? Quiz, due next time. Next class. So do it on separate paper. Don't be like, oh, I did it on the back of my notes. Just, no, have it ready to turn in. So I want you to sketch these using these 6 steps. First problem, f of x equals negative 2x squared plus 4x plus 7. Now, I can already tell you right now that the one I gave you in class just now everything was beautiful. Like it factored, everything was nice, right? This problem may not work out that clean, all right? But you should be able to execute all these steps. All right, that's the first one. Second one, that one, the first one looks worse than the second one, doesn't it? No?
Negative 11.
Yeah. Okay. I will warn you ahead of time. Yes, you're going to have decimals. Round like 1 decimal place. Okay? I'm warning you that your numbers are not going to be like super clean and pretty like the ones we just had, right? Wasn't this nice? Negative 1, 7, 3, negative 16. These might be decimals. Just be prepared for that. Any questions? Okay, we're going to get through this, quadratics, then we're going to talk about quadratic inequalities, and then we're going to move into polynomials. All right? Everybody have a great day. I would use decimals because you're ultimately going to be plotting them. And so like if you get a fraction like 11 thirds, like where's 11 thirds? You know what I mean? But if you turn it into a decimal, it'll be easier for you to actually put here. So that's my recommendation. Let me turn my camera off real quick because you're on being recorded. Yeah, hold on. Let me turn it on.